Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so let's get started. This question is just going to take us a while because we have to calculate part A. Part B would have to do comparisons. And for part A, we had to calculate two numbers. So it's going to be a little bit, but let's get started. It is, we're calculating energy, and notice the unit, kilojoules per mole. We're given two wave, FM wave, which is 99.5 megahertz, and the AM waves, which is 1,150 kilohertz. So let's get started. 99.5 megahertz. So FM, 99.5 megahertz. And then, of course, AM give us 1,150 kilohertz. 1,150 kilohertz. All right, we're trying to find energy. Before we find the energy, okay, we need to first, not yet. Before we find the energy, we need to first convert them into hertz only, because what happened is we're using the equation called E equal to H V. V is a frequency. That's the one that we're using. And in this case, the H step is a constant, which is 6.626 times 10 to the negative 34. Okay, and the unit is joules seconds. And so that means the other guy V has to be in the per seconds, 1/seconds, or also known as hertz. So that means I got to change these. So 1 megahertz, meaning 10 to the kilos, mega, 6. Okay, 6 hertz, which is the same thing as per seconds. Okay, this is the same thing as per seconds. So that means this is 9.95 times 10 to the 7 hertz, or per seconds. Either way is fine. And then this one is, again, same thing. We got to convert it. Kilo hertz, kilo meaning 10 to the 3 hertz. So that will give me at 1.150 times 10 to the 6 hertz, or also known as per second. So now I just need to plug it into here. 9.95 times 10 to the 7 versus another question, same thing, 6.6. Again, it's a little hard to write down here. I believe that might have to do with the page. 10 to the negative 34 JS. That's a unit. Okay. And then this one will be 1.15 times 10 to the 6. All right, per seconds, of course. Let's solve these. So what do you have? Time. Can I save that number? Um, 6.626 times 10 to the negative 34 times 9.95 times 10 to the 7. We're gonna get at 6.5928. Of course, I'm gonna round it, so just gonna leave it 6.959 times 10 to the negative 26. This is actually joules per photons, or joules per, right, whatever the wave is in this case. That is going to be, and then we need to change it to a mole. Okay, so in this case, this is joule per, you can say photon, joule per, I don't know, like some kind of wave. Same thing, I'm going to go ahead and calculate the other one. So I should have 1.15 10 to the 6. So we're going to get at 7.62 times 10 to the negative 28. Okay, joules per, like I said, wave or something. It's not per mole yet. So what you need to do is you need to convert each one to per mole. To make it to per moles, all you're gonna do is this. You're gonna multiply this by Avogadro number, 6.022 times 10 to the 23rd. That will convert it to moles. So I'm gonna do it to this question. So times 6.022 times 10 to the 23rd, okay, waves or something, and then that will give you per mole. All right, I don't have room here. I'm gonna actually do on another page for us. It's a little bit tight, so I'm just gonna go ahead and do this part on the other side. All right, so let me just make a new page. So pretty much what I'm gonna do is the same thing that we just did. So I'm gonna say, this is still AM, by the way. So 7.62 times 10 to the negative 28. This is joules. To get into per mole, we're gonna multiply by 6.022 times 10 to the 23rd. That will make it per mole, and then make it to kilojoules. We're gonna say 1,000 joules is 1 kilojoule. So that's what you need to do to get to the kilojoules per mole. And you still have to do the same thing to the FM, the same way, meaning this. You're gonna multiply by this part so that you're gonna end up with the answer of kilojoules per mole. All right, let me go ahead and solve this. If you have a number from previous, use a previous number so that you don't change them. 22 times 10 to the 23rd. Okay, so we're gonna get, okay, I'm gonna need to make it scientific notations. Pent. So I'm gonna have 4.59 times 10 to the negative 7. That's what I'm got for AM. All right, so I need to go back and find my FN value. My FN value is, let me see, previously. So I have previously this, 10 to the negative 26. So I'm going to do that, divided by that, multiply by this. So I will get FM as 3.97 times 10 to the negative 5. And that would be also kilojoules per mole. Now, if you compare these two, you will notice that FM has a bigger number. If you go back and take a look at it, they said calculate the wave and then tell which pair has a higher value. So this one will be FM. Okay, FM would has higher value. Okay, so that's the question to part A. Now let's try to do part B. All right, part B is giving you in wavelengths, and we are asking the same thing, energy. So for part B, I need you to remember that X-ray is 3.44 times 10 to the negative 9. So we're gonna go ahead and do that. And then microwave is 6.71 10 to the negative 2. So let's go back. We're gonna use this one to do that in this case. You have to remember that E equal to HV. In this case, they didn't give you V, they give you lambda. So we're gonna use a lambda. So I just forgotten my number. Sorry about that. Let's see X-ray. So we have X-ray. I'm gonna write it down here, what they give. So X-ray was 3.44 times 10 to the negative 9. And that will be a meter, I believe, meter. And then microwave is 6.71. So microwave 6.71 times 10 to the negative 2 meter. Obviously, now we're going to plug in here. HC, I just need the lambda part. Again, I'm going to plug in one for the X-ray. You can definitely do the same thing for both of them. So you're gonna do that, you're gonna get yourself energy. Now in this case, it is still joules. To get into joules to kilojoules, we're gonna say 1,000 joules is 1 kilojoules. And then to go kilojoules to the mole, you the number to the mole, you're gonna do 6.022 times 10 to the 23rd. And then that will be for the 1 mole. Now this is 2/23rd, by the way. All right, so that's what you have to do. Okay, so let's go ahead and solve for one of them first. So we're gonna go ahead and do the X-ray first, and then we'll do the other one. So 6.626 times 10 to the negative 34. And we also has 3 times 10 to the 8. Make sure you're entering them correctly. Divided by 3.44 times 10 to the negative 9. We are going to get at 5.78 times 10 to the negative 17. Now we're going to need to divide it by thousands. Multiply by 6.022 times 10 to the 23rd. We are going to get this whole thing as X-ray answer is as, I'm going to write it down here, equal to 3.4, actually, I'm going to write it down here, equal to 3.45 times, not 45, sorry, 48, 7, 9, so 48 times 10 to the 4, and then that would be a kilojoules per mole. That is X-ray. All right, hold on a second. So that's X-ray. I'm gonna do the other one in a different color, green. I'm gonna do the microwave in the green color so you can see. All I'm doing is I'm gonna replace this number that I wrote here for the X-ray with the microwave. So you're gonna say 6.71 times 10 to the negative 2. And then so that means I'm gonna get a new number instead of that, right? It won't be that number, it's gonna be a different thing. So let's go ahead and see what happened. Okay, so we have that times this divided by 6.71 times 10 to the negative 2. So that part will come out to be 2.96 times 10 to the negative 24, which is divided by thousands, multiplied by 6.022 times 10 to the 23rd. We're gonna get this at, instead of that, we're gonna get 1.78 times 10 to the negative 3 kilojoules per mole. So obviously the bigger one, the bigger number in this case will be this guy here, which is the X-ray. X-ray has more energy, which makes sense if you think about it. So again, the two answers are right here. There's an answer for the microwave, okay, if you're looking for it, and the circles is for X-ray. And as for who has higher energy, okay, for part B, you're gonna say X-ray has a higher energy. So again, the question for B is X-ray, and then here are the number for X-ray, and this is a number for the microwave. Now, if you go back and take a look for FM, here's a number for the FM, here is a number from the AM, and the higher energy one is FM. FM wave would have higher energy than the AM wave. All right, happy studying.